Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On February 11, 2016, a team of scientists ignited one of the greatest media firestorms in modern history. The team announced they had detected the signature of gravitational waves, or so-called ripples in space-time, which were supposedly produced by the collision of two black holes a billion light-years from Earth. Celebratory news headlines around the world have declared the, quote, discovery a definitive confirmation of Einstein's general theory of relativity. However, this is not the first instance that the world has been informed of the so-called discovery of gravitational waves. In 2014, scientists using the BICEP 2 telescope pronounced they had discovered direct evidence of Einstein gravitational waves and cosmic inflation. Yet despite the initial media frenzy, the claim was later withdrawn due to the admission that the alleged signal the team had detected was caused by a cloud of cosmic dust. Today, the chief science advisor to the Thunderbolts Project, Wal Thornhill, begins our coverage of the issue with a skepticism that has been completely absent in science media. Have gravitational waves actually been discovered? And do they even exist for anyone to detect?
The science media circus is in full swing. The headlines shriek, "Gravitational waves have been discovered. Einstein proved right again after 100 years." From an Electric Universe perspective, the irony is quite telling, since it shows the Einstein bandwagon careening off into a black hole of its own creation. Phys.org.com says, "For the first time, scientists have observed ripples in the fabric of space-time called gravitational waves, arriving at Earth from a cataclysmic event in the distant universe. This confirms a major prediction of Albert Einstein's 1915 general theory of relativity and opens an unprecedented new window to the cosmos." Once again, we see science journalists thirst for sensational headlines, with academics feeding a media frenzy. Some would call this more a theory of funding, not gravitational waves, but gravy waves. The more sensational the headlines, the more news media attention and funding potential. Unfortunately, as a result, the public can no longer distinguish science from its opposite, pseudoscience. There is no fearless investigative journalist to ask the awkward questions like, how in real terms does matter tell space and time how to curve? What does it mean to curve time when it has no physical dimension or direction? The word space simply signifies locations in 3 dimensions. So how can you weave a fabric of space-time out of non-physical concepts? The language is meaningless, used to impress rather than inform, and the scientists remain unaccountable to the tax-paying public. Some incredibly detailed claims are made, to the effect that the signal originated in the last fraction of a second before the fusion of 2 black holes somewhere in the southern sky. It is said, based on computer modelling, that the black holes joined about 1.3 billion years ago, and their mass was 29 and 36 times greater than the Sun. None of these claims can be substantiated. A mathematical computer model is not real evidence for those claims. It isn't science. The image of Einstein, the embodiment of genius, in front of a blackboard where he had just scrawled R sub ik equals 0, says it all. As Steve Crothers has noted, that simple expression says there is no matter outside the black hole. By its own definition, a black hole exists in an empty universe. No partner to orbit it, and no observer to witness it. The principle of superposition, that is, multiple bodies, in a flat Newtonian universe does not apply in the asymptotically flat space of the fictitious black hole universe. Decades ago, I sat in a public meeting at the Australian Academy of Science to hear the well-known English physicist and science fiction writer, Paul Davies, author of The Mind of God and God and the New Physics, drumming up support for government funding of the Australian Gravity Wave Telescope. Davies is a past winner of the lucrative Templeton Prize for bringing science and religion closer together. Scientists and the public don't seem to realise they were never separated. Big Bang cosmology amounts to archaic religious concepts disguised by wearing a mortarboard. I had the impudence to ask a question at the time, whether it wouldn't be a good idea if scientists understood gravity before they began spending hundreds of millions of dollars on a gravity wave telescope. The Englishman Davies arrogantly dismissed my question by suggesting that my question was typical of the colonial cringe. But after $1 billion spent on the advanced version of the gravity wave telescope LIGO, the question appears to have been answered as I had anticipated. Einstein didn't understand gravity. What's more, it appears he didn't understand light either. At the Electric Universe 2015 conference, I presented the culmination of my research into gravity since the 1980s. My choice of title, The Long Path to Understanding Gravity, reflected the difficulty anyone faces attempting a paradigm shift. As the inspirational teacher Evan Camp said at an earlier Electric Universe conference, a journey in the wrong direction of 1 mile becomes a much harder journey of 2 miles to correct. The difficulty is, as the educational psychologist Dr. Harry Linden's research shows, when confronted with evidence that conflicts with your paradigm, the usual response is denial, followed by accelerated forgetting. It requires being confronted again and again before acceptance slowly dawns. It takes both time and persistence. Meanwhile, beginners think it obvious. The first hurdle was easy to jump, and it's the one that shows the signal detected can have nothing to do with gravity. There are 2 L-shaped LIGO detectors, each about 2.5 miles or 4 kilometers long, one in Hanford, Washington, the other in Livingston, Louisiana. The 2 instruments are 1,800 miles or 3,000 kilometers apart, and since both obtained the same reading, scientists consider their discovery confirmed. The important thing to note is that the signals did not arrive at the same time in each instrument. But as Newton's law of gravity demands and simple observation confirms, time isn't involved. For example, if gravity travelled at the slow speed of light, the Earth would be pulled to where the Sun appears in the sky, and not the Sun's real position in space. This would result in a slingshot effect and toss planets out of the solar system in short order. Observations of close binary stars where the effect would be extreme and quickly noticeable show that gravity must operate at a speed in excess of 20 billion times the speed of light to prevent spiraling orbits. Einstein's speed limit of light is evidently not a universal speed limit. The Sun and the Earth have instantaneous information about their locations. Of course, quantum experiments have proven that subatomic particles know about each other instantly at great distances, but rather than state the obvious, meaningless terms like entanglement and non-locality are used to remain politically correct to the dogma of relativity. This simple example shows why we should not put blind faith in experts. Their shared beliefs have repeatedly held back progress and cost us dearly. Einstein's artificial speed limit has delayed understanding of quantum mechanics and cosmology for 100 years. That's not something to celebrate. So if the LIGO signals were caused by a gravitational disturbance, both detectors should have received it at the same instant. They didn't, so the signal has nothing to do with gravity. Then what could the signal mean? Phys.org.com reports, according to David Shoemaker of MIT, the leader of the advanced LIGO team, it looked just like physicists thought it would. The waveform that we can calculate based on Einstein's theory of 1916 matches exactly what we observed in 2015, he said. It looked like a chirp. It started at low frequencies, 20 or 30 hertz, that's like the lowest note on a bass guitar, sweeping very rapidly up over just a fraction of a second, up to 150 hertz or so, sort of near middle C on a piano. The chirp corresponded to the orbit of these 2 black holes getting smaller and smaller, and the speed of the 2 objects going faster and faster until the 2 became a single object, he explained. And then right at the end of this waveform we see the wobbling of the final black hole, as if it were made of jelly as it settled into a static state. Does this reasoning really make sense? Or is the public being baffled by mathematical abstractions? Black holes are a flawed theoretical concept used to make the minuscule force of gravity responsible for the most energetic compact bursts of energy in the universe. But black hole theory doesn't relate to the universe we observe. The problem is that gravitational dogma doesn't equip theorists to deal with the colossal energies and unrealistic mass concentration required by the theorized black holes. What can succeed without stretching either space-time or credulity is the most concentrated form of stored electromagnetic energy known to science, a plasmoid. According to the foundational principle itself, E = mc squared, concentrated energy is equivalent to concentrated mass. So, if not due to gravity, what might the LIGO chirp be? The advanced LIGO interferometer relies on super accurate measurements using laser light travelling along each arm of the instrument. The LIGO instruments have the largest sustained ultra-high vacuum in the world, 8 times the vacuum of space, keeping 300,000 cubic feet, that's about 8,500 cubic metres, at 1/1,000,000th the pressure of Earth's atmosphere, in an effort to prevent any effect on the laser beams that are being used to detect motion equivalent to the width of a single hydrogen atom over 4 kilometres. So the results obtained critically depend on our understanding of light being correct. But here again, Einstein did away with Maxwell's ether medium without explaining how an electromagnetic wave could travel through nothing. You cannot wave nothing. It is remarkable that Einstein ignored the fact that the vacuum is known to have the properties of a dielectric medium. There is no perfect vacuum devoid of matter. The electric universe proposes that the dielectric medium of the vacuum is a plenum of neutrinos, which, like all subatomic particles, must have internal structure that distorts to form electric dipoles when exposed to an electric field. Of course, the designers of the experiment didn't consider that neutrinos occupy the space inside those 4-kilometre arms. There is no way of removing them or keeping them out. They pass through the Earth as if it weren't there. Now, a linear chirp signal is well known to acoustic and radio engineers. It could signify a wave pattern imprinted at the source of the burst of neutrinos, or it could be due to a wavefront moving at an angle across the boundary between two different media. In any case, a wavefront moving across the LIGO arms will generally affect each arm differently due to simple geometry, giving rise to a slight difference in the velocity of light in each arm and producing an oscillatory output signal that's mistaken for movement of the test masses. Whatever the answer, the results of the LIGO experiment have nothing to do with imagined gravitational waves. The heart of the issue here is that Einstein didn't explain gravity. As many scientists are beginning to acknowledge, a new paradigm is now required by the sheer force of discovery. Looking back on his life at age 70, Einstein gave a clear evaluation of what he believed were his accomplishments, and I quote, "You can imagine that I look back on my life's work with calm satisfaction. But from nearby it looks quite different. There is not a single concept of which I am convinced that it will stand firm, and I feel uncertain whether I am in general on the right track." This confession, in a personal letter to Professor Solovine dated 28th of March 1949, was not made public until many years after Einstein's passing. But rather than inspire critical thinking, today's worship of Einstein creates an unresolved enigma. Two philosophically incompatible views of physics, quantum mechanics and relativity, standing side by side in scientific lectures as if such a horrific contradiction can be profitably overlooked. Einstein will continue to be proved right for another 100 years, because when all of the standards of physics, the observer and the observed, are relative and arbitrary, the theory is unfalsifiable. It's not science. Simplicity is the key to the electric universe. And perhaps a little humility wouldn't hurt either. Why not simply admit that we've hardly begun to solve the great mysteries of the universe and of our own real place in it?
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.